Okay, just had to stop the recording for a second because otherwise, if it gets too long, I can't upload it to YouTube. Okay, now, okay, so that's what we get here. And now we have our two solutions. And here we just check as well. It turns out they both are solutions. And remember, also by what I said, you can't have more than two solutions. So in other words, we have all the solutions.
So when we do this, we got to do both solutions, right? We can't just take the -2 and do it that way. We got to do it the -2 way and do it the -5 way. Find them both.
You have to find both, yeah.
Okay.
Okay, right. Right, so because with linear equations, there was only one possible solution, but with quadratics, you can only have at most two. So we found both solutions. Okay, good question. Any other questions? Okay. And really, this is just the procedure that I followed. I mean, it was already in standard form, but you want to make sure it's in standard form if it's not. And essentially what you do is you just get the right-hand side equal to 0. You may have to subtract something from both sides, interchange both sides, but that's really what you have to do. And again, this is solving a quadratic equation by factoring. Then you must factor, like we did, the left-hand side completely. In other words, you have to factor the quadratic until you can't factor it anymore. From each factor, you set each factor equal to 0, and you solve the resulting equations. I mean, sometimes you may have a factor that won't give you a solution. That can happen. And of course, it's good to check your results. Okay. All right, so that's one example. Let me do another one. I did email everyone the notes, so you should have all these as well. Okay. All right, so let's say we wanted to solve now this quadratic equation. 2x squared plus 10x plus 12 equals 0. We're going to solve it by factoring. Okay, now, notice it's already in standard form because you have a quadratic on the left side equal to 0 on the right side. You have this over here equal to 0. So it's already in standard form. So that's good. Okay, now we're going to factor. And so first, let's get our GCF. Let's find it. And we're going to factor it out. Okay, so what's our GCF? Remember, it's b times x to the m, where m, again, is the smallest exponent of x. And b is the greatest common factor of the coefficients and the constant term. So m is 0 since there's a non-zero constant term, excuse me. And now b is 2, and why is that? Well, if you were to list the factors of 2, 10, and 12, you would get the biggest common factor would be 2. I mean, you could actually see it right away because 2 itself is a factor of 10 and 12. So that would force 2 to be the greatest common factor of the coefficients and the constant term. So this is what we get. Good. So the GCF is 2. And again, let's factor it out. And that's what I'm doing here, right? I put it in front. We have to divide to get what's left over. Dividing, you divide into each term. Okay? And when you do that, right, these cancel. for instance. So those are gone. The 2's gone, and the 10 turns into 5, right? We're dividing. 12 over 2, that's equal to 6. So we get this here, 2 times x squared plus 5x plus 6. Good. So that's what we get here. And now, what do we do next? Well, let's now factor x squared plus 5x plus 6. Okay, so let's do that. So from here, right, again, it's just like the previous one. We want two numbers whose product, excuse me, I skipped a step, right? Notice we have a trinomial. There's 3 terms. The leading coefficient, as you can see, is 1. And it's degree 2. So we want two numbers whose product is the constant term and whose sum is the coefficient of x. Okay, that's good. Two numbers whose product is 6 and whose sum is 5. So of course you're going to have 3 and 2. I mean, the answer was here, but even without it being here, you should be able to see it's 3 and 2. So 3 and 2 are going to work. So the polynomial is x plus 3 times x plus 2. So altogether, when we put this in, the polynomial factored completely will be 2 times, over here, 2 times x plus 3 times x plus 2. So it has been factored completely. So once it's been factored completely, right, what we do next is we have to set each factor equal to 0. Right? And we solve to get a solution. Well, of course, 2 can't equal to 0, so that we can actually just disregard, But we have x plus 3 and x plus 2. So from x plus 3, right, you subtract 3, you get x is negative 3. From x plus 2, subtract 2, you get x equals negative 2. And so from there, our two solutions are negative 3 and negative 2. So we get negative 3 and negative 2. Those are our two solutions. And of course, we just checked as well. All right, cool. Are there any questions about this? Okay. All right. So what I want to do now is move on to the quadratic formula. So for the quadratic formula, right, this will always give you the solutions to the quadratic equation. This will always work. So once you have A, B, and C, right, it's in standard form, notice, so it has to equal to 0, okay? If you don't have it in standard form, this formula is not going to help you. So we have ax squared plus bx plus c, where a is not 0, right? And a, b, and c are numbers, though. Basically, this formula gives you the two solutions, and these are going to be the two solutions to the quadratic equation, to that quadratic equation. You have all this. As you can see, there's a square root in here, so you have negative b plus the square root, b squared minus 4ac, over 2 times a, negative b minus the square root of b squared, minus 4ac over 2a. And people generally write this as a plus minus, as you can see. It really stands for both of these, right? When you have addition, you get one solution here. When you have minus, you get the other solution. So this will always work. And again, a is not 0, so down here, you're dividing by 2a. That's okay. That can happen. And also, you might have the square root of a negative here. In that case, there are no real solutions. In this class, we're only focusing on real numbers. So you wouldn't have any solutions if you're taking the square root of a negative here. All right. Let me just change the recording.